Hello and welcome to the first episode of The Human in the Machine, the podcast of all things HCI. I'm your host, Professor Ben Cowan, and I'm here to guide you through the world of HCI. Today we're going to be talking about conversational AI, and I've put together a talk to talk about the user issues around this technology. Conversational AI has been a hot topic over the past few months, and now we're going to be talking about how the design of these systems impacts what we think they can do, and how this impacts how we interact with them. So we're going to be trying some different formats over the next few weeks, looking at talks, discussions and interviews. So please sit back and enjoy. So for the first talk today, we're going to be looking at the world of conversational artificial intelligence, which seems to have a massive boom recently with ChatGPT and all sorts of other technologies that we've actually been interacting with for quite a while. So technically, you know, your speech interfaces on your phone, your smart speakers, all these sorts of things are technically labelled as conversational AI. They have AI-operated functionality within their recognition. They use AI for synthesis. They use AI for dialogue management and dialogue planning. So one of the things I want to speak to you today is really start talking about that topic of conversational AI. And one of the areas that we speak about a lot in the conversational user interfaces community, which is one that we're involved in quite a lot at UCD, is why do we speak the way we do when we speak with conversational AI? So why do we choose the words that we choose, or why do we choose the structures that we choose whenever we're interacting? And to me, this is fundamental, actually, because it's a bit like understanding why we click on certain objects or why we use particular gestures whenever we're using gesture interfaces. So I think there's a really important question that we need to answer, and it's one that doesn't have any clear answers. So just to let you know at the start there that the answers are not clear at all, and some of the work we've been doing over the previous few years has really raised more questions than answers. But that's what we like in academia. We like more questions than answers. So a lot of the ideas from this work and from the literature more generally come from human-human dialogue literature. And within human-human dialogue, we conduct a number of things very, very quickly. And one of those is assessing or understanding or building a representation, a mental representation of what someone else might know and understand. So when you're speaking to somebody, next time think about all the assumptions that you're making about that individual, their knowledge, their what they know about the conversation. It might be something about their background, where they were at university previously, or that they're an HCI student, so they know similar knowledge to you. All of these feed into what we might say to that individual, and also how we might say it. So an example would be that if you're speaking to another HCI student, that you might mention something like mental models just off the cuff, rather than needing an explanation. Well, then you've adapted and streamlined your communication. You've streamlined your language and how you're communicating that idea for that particular person, for the assumptions you have of their knowledge. And this happens very, very quickly in dialogue, and it's a very natural process that happens in human-human dialogue. But I think the question that we have when we conduct our research in our lab in Dublin is, what about this? What about the interaction with a conversational AI? What are the assumptions that we're making about that device and the knowledge that it has and the capabilities that it has, and how is that shaping what we say and what we do with the interface? So we can use some of the theoretical propositions from human-human dialogue to be able to infer and understand what is happening with a language interface. So what's happening with a conversational AI, or understanding at least what's happening from the user point of view. So understanding what they might think the system can and cannot do. And the thing that we need to understand here is what the role of those perceptions or those mental models have about the capabilities of these systems, what role they have in engaging us in particular behaviours in interaction. The problem is, before we started researching in this area, there was nothing there. There was no real thought about what theoretical underpinning was required to be able to understand why people said the things that they did in interaction. And there was no theoretical scaffold or understanding about how people engage with conversational AI, particularly in spoken contexts as well. So what our work has been doing has been trying to kind of fill this chasm, fill this hole with theory, with research, to try and get a sense of why do people say what they do in conversational AI interaction. Now, there are a number of theories that we can borrow or use from human-human dialogue, and one of the ones that's most commonly borrowed whenever we talk about conversational AI interaction and how users generate language with conversational AI is this idea of audience design. Now, the idea of audience design is exactly what it says on the tin. So it's that you design the utterance that you're about to state to your audience and their assumed knowledge and capability as a language partner. So say, for instance, if I was speaking to someone and looking for directions to UCD, and I'd never met them before, and then they maybe had an accent, a British accent, for instance, then I might assume that they might not have as much knowledge as someone who has an Irish accent in that situation. So, and that assumption might be wrong, by the way, but it's one that highlights that things like stereotypes and simple cues can be used to guide our utterances and our generation of our utterances. And this is classic audience design. So this is where we design what we say to our partners' perceived capabilities. And recent work by Clayton Rothwell has highlighted that actually that this is probably the most common mechanism that's utilized in human-machine dialogue. So people have assumptions about capabilities of the system and they adapt accordingly. And we see this across research in the 80s and 90s, that people adapt to language interfaces and to speech interfaces. So an example here is that people use, in the research in the 80s and 90s, people were shown to use keywords or use simple grammar to be able to query speech interfaces rather than anything more complex, especially when comparing to humans, when you're interacting with another person. So Clayton Rothwell and colleagues highlighted that this is probably the likely model that's used in interaction. And that we use things such as common grounds, the assumption about the shared knowledge state and shared knowledge to be able to guide those types of interactions. We also have work from Sharon Ovias and colleagues that highlight that machine dialogue partners can sometimes be seen as at-risk listeners. This is one of my favourite quotes from a paper, because I think it does such a lot of the cognitive heavy lifting when thinking about the work and thinking about why this might, think about the theoretical, where we are theoretically right now. Machine dialogue partners are seen as that we need to support them with conversational effort. So we need to help them understand what we want by repeating our utterances, by being very clear, by hyper-articulating, which actually sometimes doesn't help with recognition, as well as being able to support as much as possible in terms of simplifying what we're stating and being very clear in terms of what we state. And so these ideas have come to the fore across the literature, across the number of years that this research has been done. And as I've highlighted before, that there's a huge amount of adaptation that goes on whenever you speak to conversational AI. So if you're speaking to a speech interface, then you probably adapt your speech based on the perceptions of the capability that it has. So you might make your speech much more simplistic, as well as I said before, you might make it a lot more, you might use a lot more keywords. You may use terms that the system has used itself, so that you know that it understands those terms because it's generated them. And you also just might be careful about the words or structuring your query in a particular way. Now, we all see this with ChatGPT whenever we're prompt engineering. So whenever you write a prompt, you may not get what you want the first time, but you may shape it based on what you think might be the best way to get ChatGPT to do what you want it to do. So this adaptation occurs all the time in language interfaces, and you see it all the time in the data in particular. So this is, I'm going to show you an example of a transcript of people adapting to, in this case, it was a Google Home, and this is in a paper actually that was published at Chi. Actually, sorry. So this is the publication at Chi that's just been accepted, and in this case, we've got people engaging with Google Assistant to try and make a recipe. Okay, so they're trying to make something like, I think it's cookies in this way here. So, first question, innocuous enough. Hey Google, how much butter do I need? Google Assistant, your speaker or smart display doesn't have a battery. So you can see that actually that query has set off a chain in Google Assistant that it thinks that it's misrecognized butter for battery. And as you can see when you go through the transcript, like I say, for instance, Google, how much butter do I need? Someone moving closer to the speaker. And then the Google Assistant going, your speaker or smart? And the participant coming in going, hey Google, how much butter? So this is a very common interaction, by the way, when you see these interactions with speech interfaces. And it's only at the end when the person adapts their speech by saying salted butter that the Google Assistant recognizes appropriately and focuses on what was on it in the recipe. Now, you could say that this was a one-off disaster. Sadly not. This is through the literature you can see all these types of disasters. In fact, actually, Martin Porstron's got a great paper in 2008 called Voice Interfaces in Everyday Life, which highlights a number of these that occur in group settings in the home. But as you can see, the speaker is trying to adapt, the participant in this situation is trying to adapt to the agent and the agent's errors and the agent's issues around this. And actually it's trying to help the system out by trying to kind of move closer to the systems with the hypothesis of thinking, well, maybe it's because they can't hear me, or maybe it's because I'm changing my word. So maybe it's because I should change my word because that will be a lot clearer. So you can see that there's this hypothesis testing going on in users that is led by a mental model, which in the terms of a conversational interface, we call partner models. Now, what the hell's a partner model? That's one thing that you might be asking yourself after me mentioning this, and this is one that we get quite a lot whenever we're talking about partner models. And it's actually this idea that I've spoken about in the earlier part of the talk, about this idea of people having a perception of the capability of the system, and that they have a model of what the system can do and what the system can understand. And so the more official definition is that it's an interlocutor's cognitive representation of beliefs about their communicative ability, and it's initially formed by previous experiences, assumptions and stereotypes. And these tend to be dynamic, so they're not a static entity. And actually we're doing a lot of work at the moment looking at how these are dynamic across time. So whether you come with a different model when you interact with a piece of software or a speech system, and that might change based on the behaviors that you experience. So if you experience all the errors we saw back there with the Google Assistant, will your mental model, your partner model about the capability of the system change? The answer is probably, but how? How does that change? And that's one of the things that's an open question at present. And so we think that these actually dynamically update based on the behavior of the dialogue and the events that happen as well that happen, as well as some aspects of the design. The aspects of the design can influence this, and I'll talk a bit about this in a second. So why would these be important? So why is this an important concept to consider? Well, over the years in the literature, we've seen that there's an element of that people use human-like interaction to scaffold what they do in human-machine interaction, so human-computer interaction more generally. So if we go back to Cliff Nass's idea of computers as social actors, the whole idea behind that was that not that people mindlessly think that these systems are humans. They don't. People are aware that these are systems, but you're using the cues that the systems are giving you, or they're using scripts that you already have an interaction from human interaction with machines. And so that these are seen as heuristics that you see in interaction. And actually we think that's probably the same thing that's going on when we're thinking about partner models, is that partner models are fueling or giving a sense of what's going on in the interaction that then helps you guide your interaction based upon assumptions that you're making about what you would do in dialogue. So an example is actually using partner models themselves. So partner models, we think, in terms of interlocutor modeling, are used in human dialogue, and that we're using them in machine dialogue here too, to fuel and to change what we say to, to our language partners. And so they act as a kind of a scaffold, really, to be able to help us to identify when we should adapt and when we shouldn't, and or how we should adapt in particular ways. And we're only just finding out how these models link to language production more specifically. It might be that it's not every aspect of language production that's important. So if you think about when you're interacting with your Google Assistant, or if you're interacting with ChatGPT, it might not be that, your choices of lexical terms that are important when doing this, or it might be that you try and be more succinct in your prompt generation, or more succinct in your utterance. So it might be that these partner models influence your syntax, or your syntactic structure of your utterance. So it might not be that linguistically they operate in the same way, and that's a very open question. In fact, there's a lot of work looking at the fact that actually lexically it seems that people do adapt a lot more based on these partner models, especially when it comes to a term called lexical alignment, which is where we copy the words that our partners use. So these seem to be quite important. One of the things to emphasize about partner models, though, is that they're not just a unidimensional monolith. They're not something that is just there, that is like this blob that then takes in stereotypes and takes in different things and informs our interaction. They're actually multi-dimensional. There are a number of different things that we consider within our partner model. And that was some of the work that Phil Doyle and Lee Clark and myself did in 2021, and some that we've got in submission, looking at this idea of them being multidimensional. So finding the facts that there's actually three important dimensions that we assess machines in terms of their partner model. And one of them being partner competence and dependability. So how competent and capable are the partners in terms of their language capability? Are they reliable, or are they uncertain? Are they efficient or inefficient? There's also a dimension of human likeness. So how human-like is the agent? Is it machine-like or human-like? Is it warm or cold, or empathetic or apathetic? What human qualities does it have? The third one here being the aspects of cognitive flexibility. So is it able to be spontaneous or predetermined? Or is it very interactive or start-stop in terms of how it operates? Or can it interpret things? Or is it very literal in terms of these aspects? These are cognitive capabilities that we assign to humans, but does a machine have those capabilities as well? And all these three are very important when it comes to assessing a machine as a dialogue partner. So that's great, but what could actually influence these partner models? Well, one of the things that's very important for influencing these partner models is human-like capability, or is the human-like design that we have seen across a number of conversational AI systems. And so we conducted some work back in 2017 looking at how people see interactions with Siri with people who are not necessarily power users of those systems. And that's actually quite a common use case category, where people only use these things every now and again. They don't really use them very often. And we conducted focus groups with those types of users, and we identified some of the key challenges in terms of interaction. What came out was really interesting from a partner modeling perspective, in terms of the fact of what's guiding our perceptions about system capabilities. And one of them is speech recognition performance. I don't think that surprises anybody in terms of how these systems operate in terms of recognizing what you want to say to them. That seems very important in forming the assumptions of capability of the system, or the assumptions of people's partner models of the system. The second one is actually one that designers kind of control, which is a human-like nature of intelligent personal assistants in this case. And this goes back to the historical aim of a lot of conversational AI work to be human-centered or human-designed by default. And my view on this is that that is entirely wrong. So we should not be looking at human focused design aspects when it comes to making them sound human-like. We should be thinking about what is most appropriate for those systems to communicate the capabilities more effectively. Now, if you think about a human sounding agent, or think about ChatGPT generating something incredibly human sounding, there's actually, it's giving itself a false quality of competence by doing that. There's not necessarily anything, it's not, say for instance, it doesn't have human emotions, for instance, like ChatGPT, although it can emote through its text, it can write emotive text. If an agent sounds human-like whenever you're interacting with it, it's giving itself the potential to be seen as similarly capable to a human agent when it comes to certain tasks. And that's just not true. That's just not the case. And so I think a lot of the time, my own personal view on this is that actually disingenuous to design something to be incredibly human-like when it comes to these things. And that's one of the major challenges that we see in conversational AI research, is how human or how not human we should be. And there are situations and aspects where we should probably be more human in certain cases. Now, this again echoes back to the idea of the media equation and the idea of computers as social actors, where there are the human-like cues might be priming us to think about particular scripts that we have in human interaction that we then enact in our interface, or in our interface interaction with conversational AI. And some of those might be detrimental to the interaction. So again, if we go back to this to the conversation analysis vignette fragment that I had on the slides before, you'll be able to see that there's that agent isn't necessarily clearly stating its capability, and the human-like nature of the system might have led the human user to feel that it might be more capable than it actually is in terms of that. Now, let's not let's not pretend that that illusion isn't wrecked whenever the interaction is goes wrong, but it's important that those initial design considerations are taken into account whenever we think about these things. And as I've said before, these types of aspects of computers as social actors are very, very important whenever thinking about that there's a sense of that, those act as cues to be able to help us guide what we're going to do in interaction. And so if those cues are built wrongly, or are communicating capabilities in the wrong type of way, it seems clear to me that that's probably a wrong-headed way of designing those types of systems. And so one of the things as well that we want to that we see with partner models is that how they actually interact, or how they impact what we do and say in interaction. Now, as I've said before, a lot of work has highlighted that these models might be incredibly important when it comes to the language that we choose in interaction. And so we tested this out by looking to conduct an experiment on word choice in interaction, and how people choose words when they're interacting with a communicative partner, particularly a conversational AI partner, or a machine partner, or someone that they perceive to be a machine. So the reason why I have an image of cilantro on the screen here when I'm presenting is the fact that this can be described in two ways, this word. So this can be described as cilantro, and this can be described as coriander. Now, when I actually first did this talk, somebody in the audience said, I asked what this was, and someone said salad. It's not salad. It's a herb. But you can say this in two ways. And that's important for this experiment that I'm about to describe to you, because this is the crux of the experiment. We wanted to see whether, if the system was designed in a particular way to communicate that it was more au fait with American English versus Irish Hiberno English, then would people change the word that they use to describe particular images? And so we conducted what's called a referential communication task, which is where you get people to name images to a partner. So you're playing an interaction game where you describe an item to a partner, and then the partner describes an item to you. Now, in these experiments that we did, we asked people to interact with what they thought was a human or what they thought was a machine. And in both those conditions, the people who they're interacting with had either an American accent or an Irish accent whenever describing the items. And the items that we were looking at in the experiment were ones that you could use these two different lexicons for. So you could use US English lexicon, you could use Hiberno English lexicon to describe. I'll give you some more examples here. So an example here would be a picture of a spanner, for instance. So you can call that a spanner, you can call it a wrench, right? So so these have different terms that could be utilized in these experiments. Now, at the start of the experiment, what we did was that we gave participants a test to ask them to describe what this would be in. To read the American English and the Irish English terms, and then we gave them a test afterwards, so that to see whether they could actually they remembered those terms. Now, this is important so that they had the knowledge to be able to make that decision in this experimental context, because if they didn't know the term, then they wouldn't be able to use it in the first place. So what we found in this case was that a classic audience design effect was that the design of the system, so if you think about this human-like design choice, which is the accent that your system might have, does have an impact on the language that people are using. So people are audience designing towards the system. People are using more American English terms whenever they're interacting with a US accented a partner, or when they're told that's a US partner, versus an Irish partner, and that's what we would classically expect in audience design, with an audience design effect. Now, this is all well and fine and dandy. This all fits with all the literature that we've had in the past. Now, this is where it gets a little bit messy and a little bit tricky, and I like it when it gets messy and tricky, because this is where you start thinking about, what are the key caveats, what are the key problems and key issues that might be happening. So the message from the experiments that we see from the 80s and 90s all the way up to the ones we ran in 2019, was that audience design does happen. Now, but there's some experiments that we've ran in the past that highlight that this doesn't happen all the time. So it might be that we're using our partner models to make assumptions about capability and competence and human likeness and cognitive flexibility, and they might be changing, but they might not necessarily just be driving our language all the time. It might not always be the case that they're doing that. And so we conducted a study, this is back in 2015, and we did a number of studies here looking at the concept of lexical alignment. So this idea where you can use the same term as your partner because you're either trying to facilitate communication success, which is an audience design way of looking at it, that you're trying to design to your audience to communicate something successfully by using the term they've used, or it's an automatic mechanism, which is thinking about Garrett and Pickering's model that looks at this idea that this happens automatically because of linguistic structures in the brain. So that it happens because you're priming a particular utterance in your lexical strata in production, and comprehension does this, and then that makes you more likely to produce that in interaction. It's nothing to do with audience design. It's not nothing to do, but it's basically there are mechanisms that are not necessarily just audience design oriented. And so this is what we looked at here, is that we did a classic, again, referential communication paradigm game where you ask people they hear a description and then they're asked to name an image in turns. Now, the images that were described to them, some of them reappeared in the game. And this is how the alignment experiments work, is that those images reappear and you want to see whether they use the same term or a different term that their partner did to describe those images. And so what we found was that there was a lexical alignment effect when occurring this. So people do align more with their partners. People use their terms, use the terms that their partner used more in general than the ones that they didn't. However, that did not change with machine partners. In the graph I'm showing you here, there's two conditions. There's a robotic and an anthropomorphic condition for a system. And the idea was that if you had a system with a robotic voice or a more anthropomorphic or human-like voice, that there'd be a difference in the level of audience design. Because remember, your partner model for a robotic agent might be less in terms of capability. So you might actually look to align more with a robotic agent than you would with an anthropomorphic agent, because of the human-like capabilities and qualities that it might be communicating. But previous literature has highlighted that humans and computers vary in this, so that the computer partner condition should be higher than the human anyway, and they're not. So they're flat all the way through, which suggests that this might actually be more automatic than partner modeling based. Now, like all good experimenters, we ran this experiment again and again and again. So we found the same result. So this is quite a robust effect that we've seen throughout the literature that we've looked at. So we've highlighted here that although there may be some aspects that we think are influenced by partner models in terms of language, they might not always be influenced by partner models. There might not always be something that is impacted by them. There also might be something that actually we produce language in a bit of a kind of lazy way. So instead of actually thinking that we're producing language to help someone else, we might do what's easier for us in language production. And then if things go bad, then we change. And that's what we were looking at in some of our recent experiments. So we're looking at the idea of what's called egocentric language production. So whether people produce language that's easier for them to produce versus stuff that's more felicitous for the system in interaction. So we actually found recently that there is an effect, that people do this to some extent, but it depends on how the system is framed. So it depends on the role that the system might have in the interaction. So through these experiments, what we did was we did exactly the same type of experiment with the referential communication games, but we changed the grids up a little bit to match some of the literature that you see in these areas where they have grids of images and they have some information that's shared, which are the white squares in this image, and then some that are not shared, that are in what's called privilege ground, which are the grey images here. So the grey images only you can see as a participant, or the computer or the human that you're interacting with can see, depending on the side that you're seeing. And the ones in white are the ones that everyone can see. So the ones in white are called common ground, and the ones in grey are called privilege ground. Okay, and so you're then asked to name an image in this here. So an example that you've got in front of you here, there's a red box in front of one of these images. You might say it's the fish, to get the person to name that for their partner, the partner to select it. Now, as I said, there are many different conditions that we had around this that manipulate common and privileged ground. And this is important because this allows you to assess whether someone is making a decision egocentrically or allocentrically, which would be audience design. In this case, you see an image at the top corner here, which is looking at an example of what's called a one-target condition. There are no competitors to what is in the image covered in red there, which is a bone, the picture of a bone. Now, picture B has a competitor image with it. So if you look at the array in front of you, you can see that the one that we're asking you to describe is the small bone, because there's a large bone beside it. And so we're using what's called a scalar modifier to be very clear with our partner which one we mean. And then you have to do that in common ground, whenever both of those are in common ground, because otherwise you end up with an ambiguous utterance. The third screen here shows the same situation as in the common ground screen, but one of them is in privileged ground. So one of them only you can see as the participant, as the partner, and your partner can't see that. Your partner's got a black box where that is and can't see the other bone. So in this case here, it might be most felicitous for me just to say it's the bone, because I'm taking the fact that the other person can't see that picture of the bone into account. However, if it's egocentric, I might say it's the small bone, because I can see two bones, and so therefore it's easier for me to disambiguate, because I need to disambiguate from my side. And this is what the experiment relies on, this exact manipulation. And what we find is that in privileged ground, we see people use fewer scalar modifiers than in common ground. So in common ground, that makes sense, right? Okay, so we'd expect that's an audience design effect. So we'd expect those things to occur. But actually, we do see people using scalar modifiers in privileged ground, which suggests that there is some element of egocentrism involved in this data as well. When we look at the system, where people interact with a human versus a computer, you can see that people are using much less privileged ground when it comes to the human condition. Whenever you're using scalar modifiers in the privileged ground condition, in the human condition, in the computer condition, and so people are being a bit more egocentric whenever they're interacting with the computer versus the human, which suggests that we're probably being a little bit more lazy when it comes to our interaction with the system rather than adapting more effectively with the system. Now, we also then highlighted this in other work that highlights that actually if you change the role of the system, so if the system isn't thought of being part of the game and it's seen as a separate entity, that changes. So it might be that actually the role of the system is important. And this has huge implications for collaborative AI. So if you're thinking about where the system should operate or not, and the type of dialogue role it takes, this is a really fascinating kind of area for these kind of work. And this is where we're going next. This is what we're looking at in the future. So what might be going on with this? So I've described that audience design is a very important part of a lot of aspects of literature in this area, and that it's an important causal mechanism for why we behave the way we do when we're creating language. And that's still true. So audience design is still important when it comes to this type of interaction. But it might not be the only thing that's going on. So we might see audience design, but we might also see egocentrism in language production. We might see us being a little bit more lazy in our language production than compared to always being alert to the needs of the system. And it might actually be that there's a theoretical view in human dialogue that's called monitor and adjust, which is basically that we might be more egocentric initially, and then we might change if there are things that occur in the interaction to be more aware of needs of audience design. So it might be that there's something to do with the interaction that changes this and that actually influences us in terms of what types of mechanisms that we're using. It also might be that the fact that if in certain situations, if we feel that the system can see everything in the interaction, no matter what, then it might be that we're actually just that the effects that we're seeing are actually audience design anyway. But those assumptions are interesting. The assumptions that we're making that the system can see everything because it's being delivered on a laptop or being delivered by a particular system has important ramifications for how we design and how we communicate the role of a collaborative AI or a role of a conversational AI on a particular system. So, for instance, when you're interacting with Google Assistant, would you assume that it has all knowledge about everything that's on your phone? Possibly. It might be that, but with a third-party app, that might be very, very different. So the assumptions of the knowledge that's shared and known within the agents is very important to what mechanisms are being used. And it also might be that this division of labour and interaction, which is being discussed a lot more in human dialogue and is being brought to the fore in human-machine dialogue, is that there's this element of that we're almost having a tug of war in interaction with who is taking the collaborative communication effort in interaction and dialogue. And so it might be that sometimes as human users, we have to put in more effort, and then sometimes the AI might take more effort, or the conversational system might take more effort, and we hang back a bit in terms of the amount of conversational effort there is to bring cooperative output in interaction. And so that might be a dynamic kind of tug of war process as we go on through interaction. And as you see collaborative AI taking hold a lot more, then we might see us needing to understand how much or how little they take on those roles, and how much that division of labour is very, very important in that form of interaction. Well, I hope you enjoyed that first episode of The Human in the Machine, the podcast of all things HCI. I've been your host, Professor Benjamin Cowan, and all that's left for me to say is stay curious and don't let the machines get you down. See you next time.